Welcome to RSET Online Lectures. Myself Bensi Wilson, Assistant Professor, Department of Information Technology. In this lecture, we are going to discuss the Module 1, Part 2 for the subject Software Architecture and Design Process IT301. In this lecture, we are going to discuss process models, agile development, and the software architecture. Prescriptive process models. A prescriptive process model strives for structure and order in software development. Activities and tasks occur sequentially with defined guidelines for progress. We call them prescriptive because they provide a set of process elements, frameworks, activities, software engineering actions, tasks, work products, quality assurance, and change control mechanisms for each project. Each process model also prescribes a process flow, that is, the manner in which the process elements are interrelated to one another. The Waterfall model. The Waterfall model, sometimes called the classic life cycle, suggests a systematic, sequential approach to software development that begins with the customer specification of requirements and progress through planning, modeling, construction, and deployment, culminating in the ongoing support of the completed software. The waterfall model is the oldest paradigm for the software engineering. Works best when the requirements of a problem are reasonably stated and well-defined adaptations or enhancements to an existing system must be made. The given figure shows the waterfall model, which is a sequential approach to software development. It begins with customer specification of requirements and ends with the deployment. Incremental process models. The incremental process model combines the elements of waterfall model applied in an iterative fashion. It combines the linear and parallel process flow. Each linear sequence produces deliverable increments of the software. The first increment is called as a core product. The core product is used by the customer. Based on the evaluation result, a plan is developed for the next increment. The given figure shows the incremental model. The incremental model focuses on the delivery of an operational product with each increment. The increments can be planned to manage technical risk. The increment models are used when the requirements of a complete system are clearly defined and understood. Rapid Application Development Model, that's RAD model. RAD model is a type of incremental model. In RAD model, the component or the functions are developed as if there are many projects. They emphasizes a short development cycle, and it is a high speed adaptation of the waterfall model. It may deliver the software within a very short period of time, that is from 60 to 90 days. The figure shows the RAD model. The phases in the rapid application model are business modeling, data modeling, process modeling, application generation, and testing and turnover. In business modeling, the information flow is identified between various business functions. In data modeling, information gathered from business modeling is used to define data objects. Next is process modeling. In process modeling, data objects defined in data modeling are converted to achieve the business information flow to some specific business objectives. Fourth one is the application generation. Here, the automated tools are used to convert process models into code and the actual system. Final one is the testing and turnover. Test new components and all the interfaces. The overall testing time is reduced in the RAD model. The prototypes are independently tested during every iteration. Prototyping model. The prototyping paradigm assists the stakeholders to better understand what is to be built when requirements are fuzzy. It follows an evolutionary and iterative approach. It serves as a mechanism for identifying software requirements. It focuses on those aspects of the software that are visible to the user. Here, the feedback is used to refine the prototype. The given figure shows a prototyping model. A prototyping model consists of mainly 5 phases: communication phase, planning phase, modeling phase, construction phase, and deployment phase. A prototyping model should be used when the desired system needs to have a lot of interaction with the end users. The next model is a spiral model. The spiral model is an evolutionary software process model that couples the iterative nature of prototyping with the control and systematic aspects of the waterfall model. It is a risk-driven process model generator. It provides the potential for rapid development of increasingly more complete versions of the software. It has two main distinguishing features. First one is a cyclic approach, in which incrementally growing a system's degree of definition and implementation while decreasing its degree of risk. Next one is a set of anchor point milestones. It's a combination of work products and conditions that are attained along the path of the spiral. The given figure shows the spiral model. A spiral model is divided into a set of framework activities defined by the software engineering team. Each of the framework activities represented one segment on the spiral path. As this evolutionary process begins, the software team performs activities that are implied by a circuit around a spiral in a clockwise direction, beginning at the center. Risk is considered as each revolution is made. The circuits around the spiral might represent concept development project, new product development project, product enhancement project. The spiral model demands a direct consideration of technical risk at all stages of the product. Agile development. What is agility? Agility is more than an effective response to change. It encourages team structures and attitudes that make communication more efficient. It emphasizes rapid delivery of operational software and de-emphasizes the importance of intermediate work products. It considers the customer as a part of the development team and works to eliminate the us and them attitude that continues to pervade in many software projects. An agile process. An agile process is driven by customer description of what is required, that is, the scenarios. It recognizes that plans are short-lived. It develops software iteratively with a heavy emphasis on construction activities. It delivers multiple software increments and it adapts as change occurs. Agile modeling. The different agile models was originally proposed by Scott Ambler. It suggests a set of agile modeling principles. First one is always model with a purpose. Second one is use multiple models. Third is always develop light models. Fourth principle is content is more important than presentation. Fifth one is always know the models and tools that we use. And finally, last principle is adapt locally. The first agile model is the extreme programming. The most widely used agile process, and it was originally proposed by Ken Beck. It contains different phases, and the first phase is the XP planning, that is the extreme programming planning. In XP planning, it begins with the creation of user stories. The Agile team accesses each story and assigns a course to it. The stories are grouped and forms a deliverable increment. The fourth step is a commitment is made on the delivery date. And finally, after the first increment, the project velocity is used to help to define the subsequent delivery dates for the other increments. The next phase is the XP design, Extreme Programming Design. It follows a KISS principle, that is, Keep It Simple principle. It encourages the use of the PRC cards. Next is the XP coding. It recommends the construction of a unit test for a store before coding commences. It encourages the pair programming. That is, two people work together at one computer workstation to create code for a story. The last phase is the extreme programming testing or XP testing. Here, all unit tests are executed daily. Acceptance tests are defined by the customer and executed to access customer visible functionality. The given figure shows the extreme programming model. Here we follow four phases mainly: planning, design, coding and testing. The next model is the Scrum model. The Scrum is originally proposed by Schwaber and Beadle. A Scrum is one of the agile frameworks for software development. Scrum is an iterative incremental framework for managing complex work, such as a new product development. The main features of the Scrum model are: development work is partitioned into packets. Testing and documentation are ongoing as the product is constructed. The work occurs in sprints and is derived from a backlog of existing requirements. Meetings are very short and sometimes conducted without any chairs. Demos are delivered to the customer with a time box allocated. The given figure illustrates a Scrum model. It contains a product backlog, which are the prioritized product features given by a customer. Next is a sprint backlog, which are the features assigned to a sprint. These backlog items will be expanded by the Scrum team members, and a new functionality will be demonstrated at the end of each sprint. We will see the different roles in Scrum in the next slides. Roles in Scrum. The first role in a Scrum is a product owner. A product owner defines and documents the product features called user stories. He prioritizes the features to be developed. The product owner controls the product backlog, means the prioritized list of product features. The second role is the Scrum Master. Scrum Master is responsible for the success of Scrum. Scrum values, practices and rules are enacted and enforced by the Scrum Master. He represents the management and the team to each other. Scrum Master conducts all the daily scrums and removes all the impediments. Next is the Scrum team. The Scrum team commits to achieve a sprint goal and have the full authority. 7 plus or minus 2 close functional team members are there in a Scrum team. The next topic is the software architecture. A software architecture of a program or a computing system is the structure or structures of the system which comprise of the software elements, the externally visible properties of software elements, and the relationship among them. The architecture is an abstraction of the system. The architecture defines how the system elements are interacted between each other. and it defines the properties of the components. The properties of the components are assumptions that one component make about another. Why is software architecture important? There are fundamentally three reasons for software architecture's importance. First one is the communication among stakeholders. A software architecture represents a common abstraction of a system that not all of the system stakeholders can use as a basis for mutual understanding, negotiation, consent, and communication. The main stakeholders are the customers, users, project managers, coders, and testers. The next importance is early design decision. Software architecture manifests the earliest design decisions about a system, and these early bindings carry weight far out of proportion to the undivided gravity with respect to the system's remaining development, its deployment, and its maintenance life. Third one is transferable abstraction of a system. Software architecture constitutes a relatively small, intellectually graspable model for how a system is structured and how its elements work together. And this model is transferable across systems. In particular, it can be applied to other systems exhibiting similar quality attributes and can be reused in a large scale. The most common software architecture structures are module, component and connector, and allocation. The role of a software architect. An architect abstracts the complexity of the system into a manageable model. The figure shows the different stakeholders: the developing organizational management stakeholder, marketing stakeholder, end user stakeholder, maintenance organization stakeholder, and finally the customer stakeholder. The requirements will be taken to the stakeholders, and an architect creates and distributes the tailored use of a software architecture to the appropriate stakeholders at appropriate intervals. Next, we will see the different roles of a software architect. First one, the architect abstracts the complexity of a system. An architect maintains control over the architecture lifecycle parallel to the project software development lifecycle. An architect stays on course in line with the long-term vision. An architect progressively makes critical decisions that define a specific direction for a system in terms of implementation, operations, and maintenance. Next, an architect works closely with executives to explain the benefits and justify the investment in software architecture of a solution. The next role is an architect sets quantifiable objectives that encapsulate quality attributes of a system. An architect inspires, mentors, and encourages the colleagues to apply intelligently customized industry best practices. An architect fights entropy that threatens architect structural approaches to problem solving. The other roles of a software architect are: an architect creates and distributes tailored views of software architecture to appropriate stakeholders. An architect acts as an agent of change in organizations where process maturity is not sufficient for creating and maintaining architecture-centric developments. In this lecture, we discussed about different process models, agile development, and the software architecture. Thank you.